So I want to talk about two tasks that I always give at the beginning of the school year to help create the kind of culture that I want in my classroom and to help promote student agency. So one task I call the river crossing problem, where I'll give students this prompt and I'll tell them that I'm interested in how many trips is it going to take to get everybody across the river on this canoe. And I'll then ask them to think about what kinds of information am I going to need in order to figure that out. And I'll have students in groups collaborate to come up with a list of questions, and after a couple minutes I'll have them share. And students are going to ask questions like, why do they want to cross? Which I know isn't what I asked, but I like questions like this because it gives students an opportunity for divergent thinking. So if they're going to be thinking about it anyway, let's give them some space to openly address it rather than have them sort of muttering in their groups. So I'll open a Microsoft Word document like this and I'll type all of their questions, not responding to any of them. Another one, question that maybe I'll say group 2, what question do you have? They'll say, can they swim across? Another one, can they push the canoe across? Like, can they shove it across? And then the money question here is ultimately like, how many people can fit on a canoe? Right, and that's really the only question that they need. But after they have all their questions flushed out, I'll go through one by one and answer them. And why do they want to get across? And you can just make up something like, there's s'mores on the other side, right? And they really want them. Can they swim across? And I'll often respond to this prompt by saying that they can't because there's sharks in this river. That gives students the opportunity to tell me that sharks don't live in rivers or don't swim in rivers, and it's a great opportunity, I feel like, for early in the year for me to be wrong and just sort of blow it off like it's not a big deal for you to say something and be wrong, and it's a little silly. And then I'll say, well, what about piranhas? Do they live in rivers? And the kids will be like, oh yeah, okay, so we'll say piranhas then. But they still can't swim across. Can they push the canoe across? No, and if you want to make up an excuse about the current, that's fine. How many people can fit in a canoe? And there's only, to be very clear with them, very explicit on this point, either it could be one child, 2 children, or 1 adult. Those are your only 3 options, and if you want, there's even a little slide here if you like the visual to show your kids, and that's it. So if they ask, can 1 adult and 1 child fit, I usually don't say yes or no. I'll say, is it one of the 3 options, and then I'll walk away. Let's talk about some extensions after the kids finish this problem. Pick any 2 numbers. Typically kids will pick positive integers, which is nice, and find out how many trips that would take. So if a kid says 7 and 11, okay, there's 7 children, 11 adults. How many trips would that take? After that, you can ask, is there any situation that would be impossible to get everybody across? And lastly, you could say, how many trips would it take for A, adults, and C, children to cross? So have them developing that sort of generalized rule here. Something I like about this activity is I've had students in the past like take a box of cap erasers and use that as manipulatives. I've had other kids take paper and rip it up and make a little canoe and then have little pieces of paper for the children and adults and physically manipulate this situation. And as we recap, I like to point out those kids, say, oh, Charlie had a really good strategy here by ripping up the paper. I thought that was really neat. And it's a good chance for us to value all different types of students in our class here, which is one reason why I really like it. And it gives me the opportunity at the beginning of the year to say, there's times when you're going to want resources, go ahead and get them. When you need a ruler, I'm not going to give you a ruler. I'll tell you where the rulers are and you can go get one. And it sort of sets that norm in my classroom that this is your class and sort of you have open access to things that are going to help facilitate your problem solving, and that part of the problem in this class, or part of something you're going to have to grapple with, is what resources do I need to solve this problem. A second problem is called lots of squares, and I start off just by drawing a square on the board, And I've seen some teachers launch this by asking students first to list everything or tell them everything they know about squares. At the high school level, I don't do that, but I think that's a good way to start it if you want. I just show a square and say, I want to know how many squares can I divide a square into. And what I mean by that is this, for example, is 1 square. So I can do 1. I could draw plus sign in the middle, and I now have 4 squares. Or I could break it up like that. I now have 7 squares. Can I do 2 squares? Well, there's no way to cut up this square to somehow get 2 squares. So 2 would be an example of an impossible number of squares to get. So again, 1, 4, and 7 possible, 2 impossible, and then I simply tell them to go explore which numbers are possible to get and which numbers are impossible to get. Now, here's a teaching moment that I've done 4 times so far, and each time has worked the way I've sort of have intended, and it's been a really powerful experience. 6 actually is possible. This is not a drawing of that, of course, but students will often have 6 blank, or maybe with an X through it, and I'll go up to the whiteboard and I'll draw this picture. And then I'll say, guys, I know a lot of you guys are struggling getting 6 squares. Let me go ahead and just help you out. Here it is. So you can go ahead and put a check mark next to the number 6. A student will often raise their hand and be like, wait, that's not 6 squares. And I'll ask them, who's the mathematical authority in here? And they'll say, well, you are. I'm like, exactly. So there's 6. And then I'll walk away. Inevitably, at least one group will start talking about this, and they'll come to the consensus because somebody will convince their entire group members that Mr. Reitmeyer doesn't know what he's doing and that this is not, in fact, 6 squares. So they'll raise their hand and they'll say, but Mr. Reitmeyer, so-and-so is right. That really aren't 6 squares. And I'll ask them, who's the mathematical authority in here? And they'll say, you, but, and I'll say, exactly. Authority means you get to say what's right and what's wrong. I'm saying 6 is right, so there's 6 squares here. Eventually, students have always pushed me on this, and someone will raise their hand, and I'll call on them, and they'll say, you're not the mathematical authority in here. Now, I've had 2 classes where when I said, well, then who is? 2 classes have said, we are, and then I'll have to prompt them a little bit further to say, so if all the students in here thought this was 6 squares, would this be 6 squares? And they're like, no. And then they ultimately come to the conclusion which I want, which is the math is the mathematical authority in here. I might make a joke that I'm still the disciplinary authority in here, but that I am not the mathematical authority. And I'll often go to my Wonderments board and write right on there, who's the mathematical authority in here. And it's a really, I think, powerful way to start the class. And just in general, if you're talking about activities that promote student agency, I think 3 qualities to look for are low threshold, high ceiling tasks. Lots of different ways to engage with the problem. So I talked about the river problem. Lots of kids use manipulative, some kids don't. Some kids use tables, some kids try to go right to the algebra. And ultimately, I think that these tasks need to get students to communicate with each other and to try to work on a collective knowledge pool. And one thing I really like about that, I didn't mention this squares problem, is ultimately the students will come to the conclusion that anything above 8 is possible. So I'll go over and ask them, well, what about 117 squares? I'm like, is that possible? And they'll say yes. I'm like, have you done it? They'll say no. Well, how can you be sure? And I think that's the power here, is them sort of developing some sort of proof for why every square over 8 is possible. And I'll often put on my Wonderments board here, what is at the heart of mathematics? And I don't address it often right then, though I will be honest, on my midterm I asked that question. And ultimately I want students to think about this idea of convincing or justification, whether they're convincing themselves or me or their peers. But ultimately, that justification is at the heart of mathematics, is what my own belief. They wrote some really cool things that weren't that. But anyway, those are my 2 tasks. I hope you find them useful.